So we are solving question number 2318, the number of distinct roll sequences. So we are given an integer n, and you actually roll the die six-sided die n times. We have to determine the total number of distinct sequences are found possible such that the following conditions are satisfied. The conditions which are being given to us are the GCD of any adjacent values in the sequence is equal to 1, and there is at least a gap of 2 rows between equal valued rows. More formally, if the value of the ith row is equal to the value of the jth row, then the absolute difference in the chain must be greater than 2. And we have to return the total number of distinct sequences which are possible. Of course, we'll have to take mod with this, as the sequences number of distinct sequences will be quite large enough. It will overflow. Now let's start with an example. So let's say we have a sequence of let's say we have been doing it n equals to 5. That means dice is to be rolled 5 times. The sequences can be 5, 1, 2, 3, 4, and 5. But in here, suppose we roll the die first time, and it comes out to be 1. It comes out to be 2. Then the adjacent, then the next value should be the value which produces the GCD of 1 with the adjacent value, so that the upcoming sequence becomes valid. Another condition is there: if we use 2 over here, then we have to skip the upcoming 2 dice. Then 2 cannot come in the upcoming sequence, upcoming 2 places. It has to come after, at least after 2 places. That means cannot come over at this place or at this place. And we can see that this problem can be broken down into smaller sequences. We just roll the die once. Let's say we just roll die once, as we rolled over here. Then the problem becomes same. Just we have to compute again n minus 1 time. So this particular problem is actually of DP. That means we can break this problem into smaller parts. Now, in order to solve this particular problem, we have to know what were the previous what were the previous two states. What were the previous two states? Let me first of all define the DP state, which will make it clear. So suppose we have been n PRV1 and PRV2. Here n is the remaining sequence, which is to be number of times which we have to roll, and PRV1 is just last value which comes when we roll the die, and PRV2 is a value which is the previous of the previous. That means if we have to roll the die n times remaining, then PRV1 is this one, and PRV2 is the previous of the previous one. Now let's code the solution. We have written count PRV1. Initially both we have not rolled the dice, so we will define it -1. Count and PRV1, PRV2. This case, if n comes out to be 0, we'll have to take it 1. Taking and now other cases are the test cases. At the nth place, we can have the value from 1 to 6, as we have been given with the 6-sided dice. And the PRV1 is not, if PRV1 is -1, that means we are just rolling the dice. We have not rolled a die single number of times. Then we will roll the die. And as we have rolled this die, then we will recur to another state. Another condition is if we have rolled die one time, if we have rolled die at least one, if we have rolled die one time only, then the number which we will be using must be producing the GCD with the last roll die 1 and PRV of 1 must not be equal to the num. Count -1. Now the condition is we already have defined, we have rolled the die at least 2 times. That means PRV1 value and PRV2 value is defined. Now we will put num over here when the GCD of num and PRV1 is 1 and num is not equal to PRV1 and num is also not equal to PRV2. And minus 1 num and PRV1. And finally we will return the answer. Let's run the test cases, example test cases. We also have to take the mod with 10 to the power 9. Let's take mod with it. Apply memoization to the solution. Then switch 6. We have defined the previous state. We have visited the state and we will return the answer to it, which is being stored in our memoized data structure. Otherwise, we will be storing it in let's see the solution works or not. Got accepted. It was quite fast enough though.